Sent a really cute one the other day. Let's see. Sorry.
Aww.
Aww.
That's a happy baby.
I know, it's really cute. He still doesn't have a name, though.
Oh.
Happy no-name baby. My daughter wants one name and my son-in-law wants the other, so they're going back and forth still. I think they have to decide by tomorrow night, or else they'll have to like pay more and go through this whole big process with the state. So I think they're waiting each other out. Like they're waiting to see. So by Thursday, he should have a name.
What are the names that they're working on?
She likes Hudson and he likes Oliver. So
You just need to put them together. Hudson Oliver's cute.
I know his middle name. They want his middle name to be his father's name, so Tate. So he'll either be Oliver Tate Huber or Hudson Tate Huber.
Oh, yeah, that's hard. Those are both cute.
Yeah, and it's fine either way. I'm like, just give the poor child a name. So they'll figure it out. I think he was Oliver yesterday, and he's going to be Hudson today. Like, they're practicing and trying them out and seeing, but whatever.
That's awesome.
I know, so funny. Anyway, I got started this week too. I'm only about halfway through, but I was the same. I think I was feeling a little wanting to be sure I knew what the heck I was doing. So
yeah, I don't like how it makes us do all the QQ plots.
Me neither. But did you see that Abby did them all? Because Abby's a rock star.
I did see the email.
Yeah.
But that was after I had already done them all.
Oh no.
The worst.
I was struggling with them a little bit, and I was like, okay, well, I'm just going to ask and then finish them after, and then there they are. So now I still have to do them myself so that I know I can, but at least for the purpose of our meeting, we don't all have to wait for me.
Yes, we don't have to all... Ooh. Doing that. Okay. Well, shall we start on our quiz?
Yes.
Let's do it.
Okay.
Okay, in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate that at least one mean is different from the others. That is true.
True. Okay. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group.
Isn't it the last two?
Yes, sir.
Yeah, that's what I thought.
Cool.
To check if each group is normally distributed, you do the following. Construct a QQ plot for each group would be the answer.
Yes, that painfully long, boring answer.
I know. Can't believe you did them all already. All right.
We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller than sample mean. The largest variance is less than 4 times the smallest variance.
Before you read them all, it's that one, right?
It's that one, yeah. Yeah.
Okay, number 7 was one I didn't quite understand, and it's probably just in the reading, but I was confused by it anyway. An ANOVA hypothesis test is equivalent to conducting 2 independent sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
Okay, so that's actually you have to pair them. Okay, hang on, I'm going to show you. It's like a really sad little drawing. Can you see it at the top of my page right here?
I close this page, I will. Show me Jenny's. Oh, that's so dumb.
So you have to make sure that everybody gets paired with everybody.
Right.
So 1 with 2, 1 with 3, 1 with 4, and then 2 with 3, 2 with 4, and then 3 with 4. So that makes 6 pairs.
Awesome.
Yep.
That makes sense.
So I had to like write it out so that I knew for sure that that's what I was doing. But
I'm gonna have to do that too. That'll be.
I'm sure there's a much easier formula to figure it out, but I had to see it all very clearly.
Right. You kind of have to you have to see what it actually looks like before the formulas make sense anyway. So.
Yeah, I did for sure. So.
Yeah.
Okay, what is the minimum smallest variance for the 6 groups round to 3 decimal places? And so I had 27.208.
Same.
Same.
Hooray for our team. Okay. And then the next one
is I got 53.158.
Yes, me too.
All right. The test for equal variances is satisfied for these data. True.
True.
And that's because of the less than 4 times.
Yes.
Yep.
Right. Okay.
Okay. Now you already constructed the QQ plots, which is just brilliant of you. I have a question about them because they don't all look normal to me. Is that just because I'm difficult? Like I think that they should be cleaner than they are, or
First set, they are close enough. In the second one, there's a little bit of weirdness with the chicken or the poultry hot dogs or whatever it was. But in our first set, the first 6 or whatever they were, A, B, C, D, E, socks or whatever it was. Those were close enough. If I remember.
close. It's just I think that I need to go back and review that lesson because I don't think so we're gonna say they're close enough.
Yes.
Okay.
Yeah.
I already turned it in, so I know that answer is true.
Oh, okay, good. Because I'm like, I'm gonna have to go back and review that lesson because I don't feel really strong on QQ plots. So
I want some help when we do the hot dog ones. We need to sit down and do the Q plots together because those ones were really complicated to me.
Okay. Because that must have been like one of the weeks that I was off the planet or something because
we really have to focus a lot on those. Like
I guess not.
Scatter plots, and that was a little bit. That's basically the same idea, right? But
yes. So question 12, then we'll finish up this data set. If you perform an ANOVA test, you will observe that the p-value is 0.081. Remove the SOX data and perform the test again. What is the p-value when we remove the SOX data around to 3 decimal places? And so I got 0.309.
Yeah.
Yep.
All right. So,
the test statistic for an ANOVA hypothesis test and an F statistic is the p-value, the area to the right or the left of the F statistic. That's to the right.
To the right. Correct.
Yeah.
All right. Now, I have not started the hot dog stuff. I mean, I opened up the data, but I haven't put it into my thing.
Graph.
I will do it right now. So, you guys, we can carry on.
Did you say that you messed up on the QQ plots that you sent us, or that you're just confused?
Just confused by the data on them. Like, there were some. 14 was the one that I had a hard time with because it's just I really don't. It was the same question as Jenny had. Like, is it close enough or is it just too far to be considered normal? So I wanted to look at the Q plots together just to make sure that. Does that make sense?
So the ones that you sent us, are they the calories or the sodium?
There are graphs for all 6 of them. So the first 3 should be calories, and the second 3 should be sodium.
Okay.
And it'll tell you there cal at the end or sod at the end.
Okay. So when I did this, I'm pretty sure that they were met because the sample variances are the same, right? Is that correct?
Let me see. Oh, why did I do that? I closed my stupid reset.
I'm putting mine all in now. Wait a minute. How is that?
Is there anything that says for the F statistic that the sample sizes need to be large?
No.
But if it's normally distributed, then we need a large sample size, like larger than 30, right?
Right, but that's the point in the QQ plots. The QQ plots are supposed to show us whether or not they're normally distributed.
Right.
So if the QQ plots, if they follow that diagonal line, they're supposedly normally distributed.
I would say that they are then, because it's not exact, but they are you can tell that they're following the line. A few of them are off, but
right. But
it's not like completely skewed or whatnot. Yeah.
1 second.
Okay, let me finally go look at those. So calories were the first 3 that you put in, right?
Yeah.
1, 2, 3. And so we're saying on calories they're pretty close. Is it the question? She has the question on the sodium one or the calories one?
Both. I got numbers 14 and 18 wrong. So.
You got 14 and 18 wrong?
Yeah, which is lovely. When I turned it in the first time, and those were my 2 weirdo ones.
And you accepted both.
So
you said that both the assumptions have been met.
14, I put down C. So the assumptions have not been met. It is not safe to assume that each group comes from a normally distributed population, but we can assume that the variances are equal. So I'm going to assume that that's wrong because they are normally distributed populations, correct? We've decided that they're okay. And I believe on the no, they were equal. The variances were close enough.
I have it open, so let me look.
Less than 4 times apart. 4 times the smallest one, I mean.
Yeah, very close. Very close to much less than 4 times. So yes.
Okay.
So then,
because they're all really close.
So then we're going to say that the assumptions have been met?
Yeah.
And the variances are equal.
Okay, so 15 says run an ANOVA test to determine if the number of calories is the same for all 3 types of hot dogs. Then it gives us all the information. Can you draw? So we're going to reject the null hypothesis. So
when we reject it, that means that at least one of the hot dog types has a different mean number.
Yeah, so we want to do the C, or the second to last one.
We want to do D.
At least one.
We know that at least one of them. We don't know that all 3 of them do.
Right.
I was thinking that the last one, second to last one, had said least of all. I wasn't reading correctly. You're right.
That's what happens when we can't see the whole question.
I know. I hate that. Don't you hate that?
Yes. Okay, now let's examine the sodium levels. Your QQ plots for the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7,180.75, and the largest is 10,492.871. Have the assumptions been met to use ANOVA? So that's not 4 times a difference because it would be 21,000, right? Ish.
Right.
Yes, it would have to be 21,000-ish. So we say they have been met.
On this
No,
one,
they have not.
Oh, they have not been met.
Yeah, because there's a little bit of an issue with the poultry one, right? The poultry QQ plot is not quite normal.
Right.
But we
Right.
can are equal.
So we say the assumptions have not been met. It's safe to, it is not safe to assume, so it's the last one. Oh, no. We can assume the variances are equal. It's the third one.
Yes, it's the third one. Good job.
I'm like, where's the one with the two right parts?
The variances aren't equal, though.
The variances are, but the population, the group is not normally distributed.
So the third answer is the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal. Though that's the one we want.
Yes.
Because the variances are close enough, but we don't know, but we don't have normally distributed population on that last one.
I don't think so.
I turned
Sorry.
Right, that's the right answer.
Oh, you got that one right.
It is the right answer. It's about the whole variance thing. Because if it's it's supposed to be less than 4 times the largest one.
So the largest one should be less than 4 times the smallest one times 4, right?
Right.
That was confusing. So the smallest one, they gave us the smallest and the largest here. The smallest variance is 7,180, so around 7,000, and the largest is 10,000. So 7,004 would be 21,000. The largest is less than 21,000. Does that make sense?
It does.
No, the whole less than 4 times is confusing the crap out of me. So the smallest variance needs to be larger than the.
No.
No.
You're going to take your smallest variance and you're going to multiply it by 4.
Right.
Your biggest variance is less than 4 times that smallest variance.
Okay.
It is equal.
Then they can be assumed equal. Yeah.
I got it. So we're doing we can assume that the variances are equal, but it is not normally
distributed.
Correct.
Okay. Yeah, I got it.
So that's C.
Okay. I have not.
Jerry wants to know the p-value for this test. I got 0.179.
Yes, sir.
Nice.
Perfect. All right. What conclusion can you draw about the mean sodium level of 3 types of hot dogs? Use a level of significance A equals 0.05. I was confused by this one because we're trying to prove the null hypothesis right in this one, correct?
Yeah, we're failing to reject.
So
right. Oh no, I lost you.
I'm confused by this one.
Okay, so basically we're saying that they are not different.
Okay.
So we're saying we have sufficient evidence to claim that they have the same mean sodium levels.
That's wrong, though.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean sodium. No, that's not what we want.
That's not what we want.
We do not have sufficient evidence to reject the claim.
There you go.
Yeah, I think it's that one. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels.
We can't reject it. We don't have enough information to reject it. That's the one we want.
Okay. That makes sense.
I think.
Well, I'm submitting, so I'll tell you in about 3 seconds.
Let's find out.
Here we go. Yep, that was correct. Right. We got them all.
How do we do?
We got them all. Good job, us. Yay! Yay! Hooray for our team.
Ahead of time every time because that made things so much easier.
So much. You're right. That is a good choice. I'm totally going to do that.
Woo!
Yay, everybody.
The midterm. What about that?
Oh, midterm this week, huh?
Yep.
Mm-hmm.
Yeah. It'll be okay.
Is that on everything we've learned or just this chapter?
Honestly, I haven't looked at the
Neither have I. Here, I'll go look right now.
The study guide?
emailed out a study guide last week.
Review for the exam. Let's see. I'm looking in the chapter to see. You know how it always has that little
Right.
summaries. So.
Oh, this is cumulative, so we need to look.
It is. Well, it looks like it starts at lesson 9.
Right.
9, 10, 11, 12, 13, 14. So the last, 5 or 6 lessons.
Yeah. We probably ought to go over the exam 1 study guide too, although that was pretty straightforward, wasn't it?
Yeah.
Yeah, pretty easy. It says make sure to go over the review for exam 1.
Yeah.
And then, yeah. So units 1 and 2 in particular go over the review for exam 1 study guide. So yeah, so I'll do that in the next few days. And then when we meet on Thursday, we can go over that.
Perfect.
Yay. Okay, everybody.
All right. Well, we will see you Thursday then.
See you on Thursday. Bye.
Bye.
Guys, stop broadcast.